Well, hello class, well, hello people. Good morning everyone.
Good morning.
Guten Morgen, buongiorno, bonjour, buenos días. Selamat pagi semuanya. Selamat pagi. Alright, before we get started, I want yourself to get yourselves settled up and prepare everything. Pens out, papers out, or anything. I'll give you 1 minute to settle up yourself. Okay, go on. Okay, have you done? Done. Okay, before we get started, I want Mr. Abdul please lead the prayer for our session today.
Get ready. Let's pray together. Pray God.
Gracias, Mr. Abdul. Okay guys, I've got introduction to reflection for our menu for today. Okay, this is one of our transformation saga. Do you guys remember on the previous meeting we already have discussed translation in it. Okay, then I want to recall something about translation, guys. Okay, anyone knows what we do in translation and what is translation? Anyone? Yeah, go on.
Sliding. Sorry.
Yes, perfectly correct. We are just sliding. In translation, or you may call it a mathematical slide, isn't it?
Yeah.
Now, we move forward, guys, one step closer, which is, it is reflection for our menu today. This is translation, a mathematical slide. Okay, and what we're going to learn for today is reflection. What is reflection? Anyone?
Mirror.
Yeah, mirror. All we do in reflection is just flipping. Okay, flipping ourselves, or flipping your figure, or flipping anything. Reflecting. Okay? Nothing we're gonna do in reflection but just only flipping our figure. Y'all feel me? Yeah. Okay. Let's start it. If you forget what is rotation, it is just mathematical turning, and dilation is mathematical change in size. That's what I've got for today. Okay, you call it mathematical flip for reflection because it's just flipping. Okay guys, firstly I've got objective, I've got vocabulary, real world context create, and you may try to identify whether it's a reflection or not, and then you may try to perform on a coordinate plane. And lastly, I will compute your score by symbol. And let's see what I've got in the objective. Okay, for today, our objective for this session is you will identify reflection, whether a case is a reflection or not. Okay, and secondly, you will try to reflect figures over the x-axis and the y-axis on a coordinate plane. Okay, if you ask me what's the meaning by over the x-axis and y-axis, let's see what's the meaning of it. Now, this is some vocabulary for you. As always, I always give you vocabulary for you because it turned out to be so helpful for you in learning this material. Geometric transformation. Firstly, transformation. What we learn right now. It is describe how a two-dimensional figure moves in a coordinate plane, and we're going to highlight these things. A transformation is a change in location by sliding and flipping or turning. And our focus for today is flipping, correct, and then changing size, or just dilation. Now, what is exactly a reflection itself? Take a look. I want boys to read the definition of reflection.
A change in location by flipping over a line of symmetry.
And then?
The figure flips over a line of reflection. You can have a reflection over any line. You may have a reflection over the y-axis, left or right, or the x-axis, up or down. The x or y-axis is the line of reflection. A reflection is always a congruent image.
Alright, we're going to highlight some sentences in here. Firstly, you can have a reflection over any line. Okay, so when you reflect your figure in a mirror, when you stand in front of the mirror, the line of reflection is the mirror. Okay, we need something that will reflect ourselves. So in mathematics, these things, it is called a line of reflection. And I've got a vocabulary for you as well. For the line of reflection, we'll see later. And I'm going to highlight the words. Reflection is always a congruent image. Do you guys remember what congruent is? Remember? Do you guys remember? You do? Yes, I do.
Yes, I do.
Next, I've got the definition of a line of symmetry. Let's take a look. Okay, so line of symmetry, line of reflection, or mirror line, or whatever it is, they are just the same. They are act as the mirror. I want you guys to read, please, this paragraph. 1, 2, 3, go.
Is the mirror line across which a figure is reflected. It acts as the mirror of your original figure to its reflected image.
Right, stop right there. So, if you ever encounter the words line of symmetry, line of reflection, mirror line, they are just the same, right? They're just the mirror of your reflected figure. You can have a reflection of any line of symmetry, and then the x or y axis is the line of reflection. The x-axis and the y-axis is the example of line of reflection it is. Okay? And then for today, for you guys, for this semester, we're going to focusing on reflection over the x-axis and the y-axis. We're not going to talk about any possibilities of line of symmetry. Our focus is on two line of symmetry, the x-axis and y-axis. Okay, what else? The last thing is just rigid transformation, which is, you already know it, I'm just gonna recall it for you. Rigid transformation is a geometric transformation that it preserves both shape and size. So it doesn't change in shape and size. Okay. That is rigid, and then congruence, the definition of it. Okay, when two figures, they have identical shape and size. Okay, so that is congruent. And I'm gonna ask you guys, is this reflection such a rigid transformation or not, based by this definition? It's always congruent. What do you think? Is it a rigid or not a rigid? Yeah. So,
Yes. Yes.
yes, okay. So reflection is a rigid transformation as translation do. Okay? So it doesn't change in size and shape, guys. Remember that. We're not going to change any. Let's see what I've got next. Right, real world context. Okay. Maybe you were wondering how this reflection of how this mathematical flip applies in the real world context. Take a look at this. Okay. Do you guys think it is a reflection? Yes, of course, right?
Yes.
So we can see a tree standing tall in the middle of the pictures, and then it is reflected over the water surface. Okay, you know this is water. Have you guys encountered yourself, the reflection of yourself on the water surface? Have you guys did? Yes, I did.
Yes.
Yes.
Yeah, that is the reflection. Basically, you're just doing a reflection in the real world context. So let's define this image, this picture, into two parts. Okay. The top part, it is the original image, or we call it pre-image. Okay, and then the bottom part is the reflected pictures, or we call it image. And in this case, who is the line symmetry? The water surface. Okay, so the water surface in this picture is act as the line of symmetry. Right? This one is line of symmetry, and then the tree on the top part is the pre-image, and it's reflected becomes image. Okay. That's another one. Oh, there's puddles in these pictures, right? So this picture is a pictures of us sitting in Europe, I guess. Let's divide this picture into two parts, like earlier. Okay, the top part is our original image, and the bottom part is the reflected image, which is we call it image. And these puddles on the road, it acts as the line of reflection, right? That was it. The real world context on reflection. If you ever encountered yourself on a water surface, your reflection is on water surface. Basically, you're just doing reflection of mathematics. Okay, y'all feel me? Any questions or clarification so far, guys?
No.
No? Okay, shall we continue then? Alright, now I want you to try to identify some cases where there is a reflection or not. That's it. Oh, I've got rules firstly. There are only two rules. Actually, there's only one key in reflection, which is equals equal distance rule. Guys, please read the definition of equal distance rule. 1, 2, 3, go.
Every point on the three images is the same perpendicular distance from the middle line corresponding point on the image.
Okay, did you get it by only reading the definition? No? I guess I gotta explain to you. So guys, this is the rules of equals distance rule. This is the case of reflection. The left trapezoid or the right trapezoid is our original figure, and the green trapezoid is our image. It's the reflected figure. The rules is every single point on your original figure should have exactly the same distance from the mirror line to its corresponding image, to its corresponding point. For example, take a look at these vertices on the very top vertices. Right? This is the original figure. Okay. Where is its corresponding point? This one, right?
Yeah.
And then the distance between this point to the mirror line, okay, it is the exact same distance from the corresponding point to the mirror line. For example, how far is this point to the mirror line? 1, 2, 3, 4 units. Right? And then its corresponding point should be 4 units away as well from the mirror line. Let's prove it. 1, 2, 3, 4. That's what I meant. And it's applicable to all other points, not only the vertices, but any single point in this trapezoid. Okay? You can think this way, guys. This is the long side of the trapezoid, right? The long side, and this one is short side. Okay. This short side to the mirror line should have the same same distance from this short side and the image to the mirror line. Okay? Are they the same distance, guys? 1, 2 units. And then from the short side to the mirror line, 1, 2 units. Okay, that was it. The rules, the key rules of reflection. So your image to the mirror line, and then your pre-image to the mirror line should have the same exact distance of your image to the mirror line. Okay, that's the key. Remember it, guys. And then the second rule is just congruent. No change in size, no change in size. These two figures is exactly the same trapezoid. It is only reflected. Okay, now you may try to identify this one. Satu orang nanti ini ya, kasih tahu alasannya ya. Kenapa ini bukan refleksi? Oke, coba, please.
Jidan.
Kenapa ini bukan refleksi ya? Alright guys, let's carry on then. So, this is the case. We don't know this is a reflection or not. So, the blue figure is the original figure, is our pre-image, and the green figure is our image. And we don't know it is a reflection or not. The question is the green figure a reflection of the blue figure? And how do you know? How do you know, guys? Anyone want to give opinion? Yes, Zidan, go on, please.
I think the green figure is not a reflection of the blue figure because the distance of the corresponding
points it's not the same.
Yes.
Okay, that was nice. That was nice. So, do you agree with Zidan, guys? This is not a reflection.
Yes.
Okay, let's try to prove it. As always, I used to tell you to get familiar with this software called GeoGebra. Because why? Because this software is totally useful for us to learn geometric transformation because it's visualization. Take a look. Alright. Okay. We're going to check this is a case of reflection. Look at me using these tools of reflection. Okay, you gotta be familiar with it with your own. I'm gonna using this feature reflect about line. So I'm gonna reflect this blue figure over this line. this image is the exact figure of a reflection. Is it the same figure with the green figure? No. Okay, so the green figure is not a result of reflection of our gray image. Do you guys get it, what I meant?
Yeah.
Okay, so this is not a reflection. What about this one, guys? Okay, I've got two triangles. Okay, the blue one and the red one. The question is the red figure a reflection of the blue figure? And how do you know? Anyone? Okay, please go on, Ice.
No,
Yeah?
because the size not same.
Exactly. That's what is the key. Remember, reflection is congruent, so no change in size. Since the red figure is bigger than the blue figure, without even visualization, okay, we know in this case it is not a reflection. Lastly, what about this case, guys? How do you consider this case as a reflection or not? Anyone? Okay, Gia, go on.
Because the distance of
Yes. The yellow, the bottom side.
the distance of the two triangle is the same.
Okay. Okay. I know what you meant here. You mean is the bottom side of the yellow triangle
Yeah.
is the exact same distance
With the bottom.
with the bottom side,
Size of-
the blue triangle
Yeah.
to the mirror line. Sorry for the disruption. Right. So this is a reflection. Okay. Now you have known what is a reflection, and you have already identified it. Identified cases whether it's a reflection or not. You guys feel me so far?
Yeah.
Okay. So we continue then. Any questions or clarifications?
No.
sir.
Sure.
Right. Okay, now you have identified it. Now let's try to perform it. Let's try to demonstrate it on a coordinate plane. Okay? I will give you an example firstly. Okay, first we're going to reflect over the x-axis. Okay, and in the second one we're going to reflect over the y-axis. Firstly, reflection over the x-axis, guys. I want you to read fast the definition, please. 1, 2, 3, go.
As a mirror and reflect each point over the same distance. Label each reflected point with a stroke.
Alright, we're going to highlight the sentence, use the x-axis as a mirror. Okay? We are reflecting over the x-axis. So we're going to use the x-axis as our mirror. Okay, let's try to the example. Okay. I've got triangle ABC. Reflect the figure, reflect this triangle over the x-axis. How do we do it? Okay. As always, we're going to use our lovely software called Judul.
Yang 5.
Okay, before we reflect this figure, we got to know the coordinate of each point. Firstly, point A, what's the coordinate? Everyone?
2.
2 and 1.
Yeah.
1. What about coordinate B?
1 and 4.
1 and 4.
4.
Lastly,
6 and 6.
6. Right, as always, when we're going to transform a figure, don't think about it as the whole figure. Okay?
Yeah.
Even though we're going to reflect the whole figure, but the way, don't think about it to reflect the whole figure. Think about it as the points. Okay. We're going to make use the vertices of this triangle. So we're going to make use of point A, point B, and point C. And each point, we're going to reflect it over the x-axis. Which one is the x-axis? The horizontal or the vertical one?
Horizontal.
Horizontal, sorry. So if this horizontal line is your mirror, then where would the image be? What is it? Where will it be?
Under.
This one?
Yeah.
Okay. You guys know this sector is called fourth quadrant.
Yeah.
Okay. So the image of our triangle would be right here. Okay. Let's try to reflect it one by one. Each point. Firstly, from point A. The rules is just one. The distance is the same. Okay. How far is the point A to the mirror line?
1.
One, right? Is it only one? unit.
Yeah.
So the A prime or the image of point A should be on 1 unit away from the middle line. 1. So we're gonna make the points here. What is the coordinate of this point, guys?
2
2 and negative 1, right? Rename it. What we labeled of an image? It is prime. Okay, A prime. Now, B point. Okay, guys, how far the point B from the middle line?
4.
4 units. So the image of point B should be 4 units away from the middle line. And then it should be right.
Negative 4.
1, 2, 3. Yeah, it's negative 4. So we're gonna make a point here.
1 and negative 4.
Show level. Name is B prime. Right. Now lastly, point C. Okay, how far guys? The point C from the middle line. 6 units away.
Yeah.
And then we're gonna. By the way, it should be perpendicular direction, okay? Straight down. No, we're not gonna do it in diagonally. It should be perpendicular. 6 units away from here should be right. Then this point is negative 6.
6 and negative 6.
6 and negative, right? C prime. Okay, now, after we have done reflecting each point, all we do is just connect each point with a line.
Yeah.
Okay? You can use this feature, polygon, and connect it. And there you go, our image, or reflected image of these lines. I'm going to ask you, is this image make sense, guys? Is this a reflection of the pink triangle, is it?
Yeah.
Yes, now we've got it. Let's try to plot the points. A becomes A prime. Oh, wait, let's check it out, let's check it out. Let's check it out, let's work on that by using these tools. Reflection about the line, I'm going to reflect this figure over the x-axis. Yes, exactly. So what we did is just a correct way. Now, let's take a note. A, 2 and 1 becomes A prime. What is the coordinate of A prime, guys? 2, negative 1. 2, negative 1. What about B prime?
1 and negative 4.
1 and negative 4. C prime?
6 and negative 6.
Okay, pay attention. Point A reflected becomes, point A, 2 and 1 reflected becomes A prime, 2 and negative 1.
Yeah.
Right. Point B, when 4 reflected becomes 1, negative 4.
Yeah.
See? 6 and 6 reflected becomes 6 and negative 6. Do you guys encountered any pattern of this case?
Yeah.
What's the pattern?
Yeah.
Yes,
The
yes,
Y.
exactly. The Y value is changed,
Yeah.
is it? It becomes, from positive, becomes negative.
Negative.
Positive, negative, positive and negative. And X value still remains,
Yeah.
right? So that is the pattern, guys. If you reflect a point over the x-axis, it becomes A prime, and the only value that changes is the Y value. That was it. If you want to reflect a point, all you need to do is multiply your Y value by negative 1. You'll know how to do it.
Yeah.
That's the thing. The rule is only one, is its congruence, is it the equal distance rules, and it's common. Now, shall we continue then to a reflection over the y-axis? They are just the same. The difference is only we're going to use the y-axis as our mirror. Okay? Earlier, we're using x-axis as our mirror. Okay, so now we're going to use the y-axis as our mirror. Take a look at this one, guys. Okay, now we're going to reflect it over the y-axis. We're going to use the same triangle. Right? I'm just going to repeat it. still the same triangle as earlier, guys. So, but the difference is we reflect it over the y-axis. Where is the y-axis? Horizontal or vertical?
Vertical.
Vertical one. So where would the image be? On the left side, bottom side? Where would it be? On the left side. Okay, so the image would be right here. Now, we do it the same as earlier, right? Point A, point B, and point C. Okay, take a look. How far is our point A to our line of symmetry? 2 units away. So, it should be right
Negative
here.
2 and 1.
Okay. Alright, how about point B, guys? How far it is? 1 unit away, isn't it?
Yeah.
1 unit away, should be here. Lastly, point C, 1, 2, 3, 4, 5, 6 units away. Okay. Let's try to reflect it. It is correct or not?
Yeah.
Over. Yes.
Yay.
Perfectly correct. Okay, now let's take notes. Point A, 2 and 1 becomes A prime. Negative 2
And 1.
and 1. Point B,
Negative 1 and 4.
lastly, negative
Negative
6.
6 and 6.
Okay. What about this one? Do you guys see any parts in here? Do you guys see it?
Yeah. The
If we reflect a point over the y-axis,
and
it
the
becomes
value
8.
x is negative.
Perfectly correct. So our x value becomes negative. Or if you reflect a point over the y-axis, you're going to multiply your x value by negative 1. Right? Okay. So this is the pattern. Reflection over the x-axis, we change our y value. Multiply it by negative 1. And then reflection over the y-axis, we change our x value. We multiply it by negative 1 as well. Okay? Guys, please take notes of this one.
Yeah.
Alright?
Okay.
Now, I guess it's time for lunch break. These 2 questions, these 2 examples is for you. But we don't have time anymore. I guess you will do it in home. Alright? I've got 2 questions. Firstly, a reflection over the y-axis, and the last question is a reflection over the x-axis. These 2 questions will be computed by me as your score, and this is your sheet work at home.
Okay.
And guys, one last question, one last instruction. Take a look. Find the coordinates of P prime, Q prime, and R prime. And I don't want you to find only the coordinates. I want you to plug. I want you to plug the figure. Triangle PQR. You plot it on a paper, and then triangle P prime, Q prime, and R prime. And then as well, you plot it on a paper. You guys got it? Y'all feel me?
Yeah.
And I recommend you to do this sheet work on a paper called millimeter block paper. Do you guys know it?
Yes.
Alright?
Yeah, I know.
Okay then. I guess that was it for today. Course completed. Do you guys have any questions or clarifications?
No.
No? Alright then. So, next week, guys, we're going to continue our transformation saga. Okay? Rotation. We've done translation. We've done reflection. So, in the upcoming meeting, we're going to talk and discuss about what is rotation. Alright, everyone, if you don't have any questions or clarifications, I guess that was it for today's session. And I want you to get familiar with the software I use, GeoGebra. It will help you a lot in learning and in defining geometric transformation. Alright, I guess that was it. Please, Mr. Abdul, lead the prayer for closing the session.
Ready? Let's say together. Play done.
Okay, I guess that was it, guys. So, adios, everyone. Cheers.
Thank you.